Hello everyone. So in today's session, we are going to learn about series and parallel combination of our resistance. So here you can see we have resistance. So all the resistance which we have here are of same value, that is 1 kilo ohm. And we are going to see what is the difference between series and parallel combination between our resistance, that how the value differs. For that, we are going to use multimeter to measure the values. So first start by measuring the values of our resistance. As I have told you that each of the resistance are of same values. So let's see what is the value of a single resistance. So for that I have to turn it on, make it to the resistance section. So here we have the resistance one. Let's start below, that is your like the lowest one, 200. So if I check it, you can see it is showing you 1. So 1 means like it is maximum, like it is more than this value which it is currently showing. So I have to switch it to the larger value. So let me again here you can see it has a value of 985 around, means it is 1 kilo ohm resistance. Okay, because I have the my model is into 2 kilo or 2k, so it is around 1 kilo ohm resistance. The value of this resistance is 1 kilo ohm. Now what I have to do, like this single value is 1 kilo ohm, so I have three more, like total I have four values. So I have two options for combination, that is a series combination and a parallel combination. In series combination, what does happen? The combination are like this, one after another, like this. One is linked with another, like the end of it is the starting of the another resistance, and the second end is the starting of the third end, and similar one. So this is your series combination. And in parallel, we have like some structure like this, like they are all in same. Okay, so this is your series and parallel combination. Now let's see how the value differs. So for that, what we can do, let's first start by creating a series combination. So I have plugged in the first pin is like this. Here you can see like this. Now let's again do the same for the second one. Similarly for the third one. And finally the fourth one. Okay, so this is my all are in series, like the first starting from here connecting with this one is second connecting with your third one is starting and ending connected with the fourth one, and so on. Now we are going to use two jumper wires here. This is the starting point, and second is from here. We have these 2 points which will show us the series combination value. Okay, so let's go to our minimum one, that is 200. Let's check from the minimum, connecting both of the end. Okay, so here it is showing 1, means it is greater than this value. Let's switch to 2k. I have a value that is also greater than this. Let's switch to 20k now. Okay. Now I have a value like 3.92. So if you remember that previously when I was only testing a single one, we have a value around 0.98 or around like 1 kilo ohm. Now we have all the four are in series, and we have a value of yours around 3.9, which is 4 kilo ohm. So in series the resistance values are added, like if we have two resistance of same value, let's say 1 kilo ohm and 1 kilo ohm, so they will be added directly. Okay, it will be shown in a paper. Let me show you, it will be better understand. For example, let's say in series, so the total resistance, that is your R total, this is my total resistance which we have, RT is equal to the sum of your individual resistance, that is R1 plus R2 plus R3 and so on, that we have. Now the R total here equals to, like we have the first resistance as a value of 1, second is also 1, third is also 1, and fourth is also 1. So they will be directly added, that is your 4 kilo ohm. Okay, this is your R total. This is your value of your resistance, total resistance in series. Now what we are going to do, we are going to see the parallel combination. Okay, how the parallel combination differ from your series one. So let's put this aside. So as we have seen in the parallel combination, what we have like both of them combined in on a parallel combination, like both of the points are in contact with each other. So let's create them. So let's put them here. First one, this is my first one. Similarly, I have to put them with the same hole vertically. Then the second one, similarly the fourth one. So here if you see, like all of them will have the same points here and here. Okay. Now let's use similarly two jumper wires, one from here, one from the another end. Okay. Now let's see what are the values that we get. So start by the lowest one, that is our 200. Here we have 1 means the value is greater than this. Let's switch to 2k now. Okay, we have a value that is 0.24. Okay, now let's see how the value is 0.24 when a single one measures your 1k. Okay, so let's see. So let's grab our paper. So this is a series combination. Okay, now we have the parallel combination. So in parallel combination, what we have, this will be like 1 upon RT, that is your R total, which will be equals to 1 upon R1 plus 1 upon R2 plus R3 and so on, like that we have. So let's see how the value we got. So 1 upon RT equals to 1 upon 1 kilo plus 1 upon 1, 1 upon 1 plus 1 upon 1. Okay, because all of these are 1 kilo ohm and we have 4. So 1 upon RT equals to 1 up, like it will be 4. Okay, 1 plus 1 plus 1, 4k. Now if we see the value of RT, so RT will be 1 by 4. Okay, or actually 1 by 4 k or 4000, so it is like 0.25, right, kilo, right? So we have this value. So if we check it, so we have this same value. Okay, so this is how the series and parallel values are differ from each other. Now, so this is a series and parallel combination of your resistance.